What's going on, everyone? It is John here from ContraBIM, and we are back with another tutorial on Archicad. In this session today, we are going to be talking about roof pitch calculations, and we are going to be using a lot of expression-based properties. So if you are interested in learning all about expressions when it comes to slope and creating custom pitches, then this tutorial is for you. So we're going to cover a lot here in today's video, and hopefully by the time we get through it, you'll have a much greater comfort level with using expressions as well as how to convert different slope angles. And we should have some fun along the way, and yeah, looking forward to this one. So if you haven't already seen our previous video, we actually did one where we did take degree slope and converted it to percent slope. We were applying it to a mesh in that case for more of a civil sloping type calculation. This exercise here is really going to focus all about roof pitches, which we will look a lot at ratios. So we'll talk about using fixed ratios, whether it's 1 to a variable number or a variable number to a fixed ratio as demonstrated here. And we'll also get into fractional ratios, which can be really useful when you have a number less than 1 to 12, which is quite common here, at least in the US. For those international users, then this may not be as applicable to you, but hopefully you can learn a few things along the way as well. So let's take a look at a few sample slopes here. So a 1-to-1 roof pitch ratio essentially results in a 45-degree angle. So that would be our degree pitch in this case. Our percent slope would be 100%, so we're going up 1 unit for every 1 unit that we're going forward. And you can see here our roof pitch ratios, of course, are 1-to-1, or if we look at it in a fixed number there on our run, it would be a 12-to-12, and all that makes a lot of sense. Pretty straightforward stuff. Now, if we start taking a look at another example here, such as a common, very low sloped, flat type roof, say a 1/4 inch to 12 inches slope, then we start looking at these numbers, and all of a sudden our degrees is not a number that is very recognizable. Our percent slope it's slightly over 2% here, but again, it's not a very common number for us to look at. And these numbers are a little bit, it takes a little bit extra understanding and conversion for contractors and people who might be reading your plans. Even a 1-to-48 or a 0.25-to-12 are not common numbers that we typically see when we have designated slopes. So in this case, our preferred would obviously be just our 1/4 inch to 12, which is no problem to type out, but it's a little bit different and a little bit more of a challenge to actually generate this when we are assigning an auto label to a roof element that's going to go in and actually extract out the results into this type of format. So that's what we're going to be exploring today as we get further along into this video. So okay, let's talk a little bit about kind of our first step here, which would be our degree slope to percent slope. Now again, we did a video on this recently. For the purposes of this video, we're going to be using the term pitch a lot, which is a roof parameter that is our degrees slope. So you'll see how that comes into play here in our expression-based formulas. But the formula that we're going to be using for this is our percent slope equals the tangent of the pitch times 100. So this is a very simple formula. We'll get into the expression editor and we'll set this up, and this will kind of be our baseline starting point. From here, and of course, we'll output this into a number format because it essentially results in a number format. If we did want to tag on that percent on top of that, then we'd have to convert that to a string and concatenate that with the percent symbol. But for the most part, we can just leave this as a number format. Okay, next up is our pitch slope ratios. So this would be a rise over run type scenario. And in this first example, we're going to look at a fixed rise where we're going to set the rise to 1, and we're going to let the run be variable depending on what the slope of the roof is. So the way that we're going to set this one up is we'll concatenate that first part, the fixed part, which is going to be the 1 with the colon in this case, and then we will add the run to the second part of it, and we'll find the run based on the pitch. And of course, this calculation is going to be the run equals 1 over tangent of pitch. So that will be our next formula, very similar to the first one, but slightly tweaked. So, okay, and of course, our output here is going to be a string format. Anytime you start concatenating things, it's always going to be a string, essentially. So yeah, we'll talk about adding strings there to convert units to text, essentially, and allow this formula to function. Okay, moving on. We have our other version of this, which is our pitch slope ratios, where we have a rise over run with a fixed run. So oftentimes here in the US, we'll want to see things over a fixed run of 12. So that's, you know, because we work in feet and inches, often seeing inches over the standard 12 inches is going to be useful. And so that's what we'll do in this formula. It's going to be a little bit different, but will yield a similar type result that's just kind of the opposite. So in this case, we will set this up with a rise equals the tangent of our pitch multiplied by our run multiplied by our multiplied by our fixed run, which in this case is 12, so that those units are alike. Okay. And of course, I'll put it again to a string. And then finally, our most complex and detailed formula that we are going to set up here is going to be one where we have a rise over run, and we are going to set this up for fractions that are less than 1 inch. So in this case, we're actually going to be rounding this out to a 1/8 inch interval. And it's really pretty straightforward to actually have this automatically calculate through to be a 1 over 16th, 1 over 8th, 1 over 6th, even 1 over half. But once we get beyond 1 over half, then we start to flip a little bit there. And when we go to say like a 3/4, it really throws a wrench into our setup here, where it makes it very difficult to output say a 5/8 inch or a 3/4 or a 7/8 inch. And so we're going to take this a little bit different. We'll take a different approach to this, and we're actually going to stack up several if statements rounded to 1/8 that are going to give us the ranges of degrees depending on which slope we are looking for. So this one's going to get a little bit more complicated, but it's kind of fun to set these up as well. So we'll be going through a lot on this one, and yeah, I hope you enjoy. Actually, at the end of this, what we'll probably do is we'll combine some of these different expressions so that we have a scenario where if our pitch is greater than a 1 to 12, we'll use one of these outputs. If it's less than a 1 to 12, meaning one of these fractions, then we will use, of course, the fraction. So that will be a pretty large formula when we get to the end of this video, which we're already 8 minutes in here. So buckle up. It's going to be a longer version, but you can always scrub through later on and pull out the content that you want. But before we jump over to Archicad, if you like this type of content, then make sure to like and subscribe to this channel. If you want to learn more about expression-based properties, then go check out ContraBIM.com. We are actually putting together a full course on expressions that's going to go and cover a lot of different scenarios that you may find useful in your Archicad projects. So definitely go and check that out on the ContraBIM.com website. And we will be launching that course here sometime later this summer or into the fall. So, okay, let's jump over to Archicad. All right, so here we are in Archicad. You can see we have our sample project. And the first thing I want to point out before we start diving into these expressions is we do have a roof label that you can see here. We're going to just select one of these roof labels, and you can see roof label, slope label USA. If we take a look at this, this will already give us that ratio output. In this case, it's a 15:12 slope. Now, we can't change any of our units here, and it starts to fall apart when we go less than 1. So, for example, here with this flat roof condition, we are at 1/4 inch. If we set this to 1 inch, then it works okay. If we go anything less than that, like a 1/2 inch, then, well, I guess it rounds up in that case. But if we go to 1/4 inch, it's going to round down to 0. So that's where it starts to fall apart. The other thing that's kind of weird with these is just the direction of the arrow. So like if I picked up this label and I tried to apply it to this roof here, like it comes in angled, and then you got to get in here and you got to play around with where is it? It's this one right here to get that to flip around and go in the other direction. So it's not so bad once you get the different directions figured out on your project, and it's easy to copy around, but it's not quite as easy as if we wanted to just place an arrow in there and then have a auto text. So yeah, that's what we are going to begin with here. And really we're going to be focusing on this kind of flat roof here that we've already established is this 1/4 inch in 12. You can see that we have these different inputs here. So when we change that, we can see we get our percentage, we get our inches in 12, or sorry, that last one there was in 12 feet. This one is in 12 inches. So that's really the input that we're accustomed to. Now I will note, if you are your project preferences, if you are set to meters in this case, I'm just going to flip this over really quick just to show you. You will not get those additional inputs. So if you're working in the metric version, then you probably don't see those because it's in metric and there is no rise over 12 inches or rise over 12 feet. So just wanted to point that out. But I believe the international version should make those available if you do switch this over into your, in this case, we're going to be feet and fractional inches. Okay. So, all right. So once again, we are starting here and we are going to be building this up in a few steps here. So just to reiterate, our first version here that we are going to be building is going to be our conversion of essentially our degrees to percentage here. So that's a very simple formula, and we're going to jump into our property manager and start tackling this out. So, okay, the location that I'm going to add all of these in, and I did this in the previous video with our sloping on the mesh values, is going to be under, I have a category here called surveying. So really, to me, this is kind of like it's a little bit of a random type output here, and often with this it's kind of related to surveying and slopes and this type of information. So that's why I'm just going to tuck it here under my surveying group, but you can create these new properties really wherever you want. So again, so it's going to be very simple formula here, and let's go ahead and create that right now. So we're going to set this up. I'm going to just create a new property called percentage slope. Okay. And as we get going here, I'm going to go into our classification assignments, and I want to make sure that this is turned on for our construction elements that are, or sorry, not element assembly, elements, construction elements. I'm going to turn this on for all of our different types of roofs, as well as coverings that may have this slope as well. So I'm just going to turn it on to all of those so that these will come through. And yeah, that should be really the only ones that are applicable in this case. This could potentially apply to beams if we wanted to use these for beams. So we'll do that as well. And I suppose a ramp, it can also apply to a ramp. And as I'm thinking about it, there's probably going to be other things, but for now, we'll just go ahead and work with those. So we've now made this available for those different classifications as part of the Archicad classification version 2.0. Okay, let's get into this. So we are going to be setting this to a number. That's our data output, and we can see the value there. So that's going to be a nice expression output for us in percentage, and we are going to go in and create a new expression. So if you'll recall, our formula here is going to be a trigonometrical function, and we are going to take the tangent of our angle, and our angle in this case, if you'll recall, it's going to be our roof pitch. Now for those other types, as I'm realizing this, we have our beams and some of those other types that may not actually be modeled with the roof. If it's modeled with the beam, then this pitch won't work. In the past, we've actually created another one here that combines the roof pitches and the beam slopes into one property so that we can get by with that. But in this case, we're just going to continue right along because we don't necessarily need that. So We can always come back and fix that later on if we want. But anyway, so this is our tangent pitch, and we can see there is our setup there. Now, as I'm saying that, I'm thinking, I'm going to kick myself later on if I don't set this up the first time. So we're going to back up, and we're just going to create that angle degree so that it is, we're kind of future proofing this here a little bit. So, and we can call this is really our pitch. And in fact, we can just call this pitch, which is angle degree. And in this case, what we're going to do is we're going to come in here, and all we want to do is we're going to, first of all, let's go back into our roof there, and we're just going to list our pitch. And so, okay, so there we have our pitch, and now we're getting a little bit of an error here because we haven't set our data type. This is looking for an angle, and of course these are always going to be angles, so all we need to do is set this to angle, and that should work out okay. So our next one here is we're just going to go in and look for those other conditions that may apply. So our beam, let's see, our beam slant angle, where is that? Okay, so there we have it. And okay, so now we've combined these up where we have our pitch and our beam slant angle. And we also have one other that I can think of, and I think it's under our general, which is a slant angle. I'm not sure what tools populate that. I think the beam may, but I don't think the roof does. But we're going to add one more condition here as well. So, okay, so now we've set these up where we have our pitch, which is our angle, and we can reference that now into our slope percentage. Now, I've already gone in and I already set this to the other pitch that was coming from our roof here. So all we're going to do in this case is we're going to go down to our properties. We are looking for our schedule, not our schedule, our survey, which is 0, okay, right there. And then we're just going to replace that with our pitch. So didn't really look like it, but we double click that and it did replace it. So we should be good with that now. So now we're going to go and look, and what we'll do is we're going to list both of these, and yeah, we're going to start building up on this label that we have here, and we're going to take this one, which is a text, Autotext. We're going to dive into it here, and let's just start listing some of these properties. And we're going to just build this up as we go so we can see all the different variations. So, okay, so under our surveying, we have our percentage slope, which I need to double check here what's going on. So let's see. So this is a roofing classification. Let's go back in and double check. So our percent slope. Okay, so this does not have any properties. That's why it did not go through. I thought it did when I set that up. But what we're going to do is we're going to pick up the settings, and we're going to inject these settings, and by doing so, it should make that available. Now, because this is an auto text, and we know that this is a percentage is what our desired output is, then we can take this and we can just type in a percentage. It's as easy as that. The other thing that we can do here is we're going to go back in, we're going to pull out our pitch, and so now we can see, okay, let's double check this. So there's our degrees, and we're going to select our roof, and let's just do a quick check. So there's our percentage, which we can see is 2.08. Our degrees is 1.19. So far, so good. So that was our first setup here, which was the output of, or the conversion of degrees into percentage. So, so that can be useful for labeling in this case. Okay. The next one that we are going to get into is going to be another property that will be our slope pitch ratio. So in this case, we are going to, we're just going to create a new property. I'm going to call this a slope pitch ratio. And this is the one that we're going to set that's going to be a 1-to-1 variable. So we're going to give it that little preview there so that we know exactly what this one is that we are working with. Now this is of course going to be a string. Number one here, let's go ahead and we're just going to pick up and inject our available classification so that it is there and ready for us. And so next step is let's go in and generate this property. Now, as a quick recap here, I'm actually going to jump back over to our slides, and I'm going to pull this up just as a little refresher. And what we are going to be doing is, not that slide, we're going to be doing our rise over run, where we have a fixed 1 as our rise, and then we're going to let the run be determined by whatever value that is. And we're going to concatenate our 1 plus our run, and we're going to find this through the formula of 1 over tangent of our pitch. So that's the formula we are going to be working with. And so, okay, we're going to jump back here, and what we'll do is we will start this out with our concatenate, and then we will build things out from within there. So first step here is it's concatenate is our merging of strings, and so that gives us our first text, and our first text we know is going to be a 1 with a colon. So okay, so that takes care of our first condition here. Now our second condition, I said it was going to be our 1 over the tangent. Where's our tangent? There it is. Tangent of our pitch. So we are going to go in here and surveying. There's our pitch. So, okay, so this is our second formula here. Now we can take this, I'm going to cut it, and I'm going to paste it here in our second condition, but we have a little bit of a problem here. And that problem is due to the fact that, well, one, we have a syntax error, but even if we put this on at the end, it says our argument's data type is not correct. The argument expects a string value, and this is not a string value. So we need, when we're concatenating, we need to merge two strings. And so to convert this to a string, we need to go into our data conversion and we'll convert to string. And so our value in this case is going to be exactly that we started with here. So we are going to cut this and we're going to paste this in. Okay. And then our number of decimals here, I don't think we actually even need those. So we're going to remove those out and we're just going to let this run as we want. So, so we can actually add that back in. If we give it 1 decimal, then it will pull a decimal in. If we leave it as 0, then it will not. So that's something that we can just kind of remember. And yeah, so we're going to just kind of roll this all up into 1. And right now we're not getting any errors, so that's great. And let's go ahead and see what we get when we add this slope pitch ratio of 1 to whatever the run is. So, all right, let's jump into here. We're going to go find that value. So slope pitch ratio. And okay, so there we can see it. And all right, so that is that working? Well, let's go and check. So a quick way that we can check is if we go and we set this to an input that we know is consistent. So if we set this to 1 inch, it goes to 1 to 12. So that is absolutely working. If we go to 4 inches and 12, then we can see that this is, again, it's always the same ratio. So it's 1 to whatever that value is. So in this case, we're just calculating whatever that is. If we go to 12 inches in 12, then we can see it's 1 to 1. If we go to 2 feet in 12, 1 to 0.5. So we can see that that number is always going to change. This number is not. What's kind of interesting as we do this, you can see that it is changing this location of that label, which I find is interesting when we change the pitch, because obviously we went from a very shallow pitch of 1/4 inch, which apparently is 1 to 48, to something that was much steeper, and it actually moves those labels for us. So it's kind of interesting. Now let's play on this a little bit more. We are going to go back into that formula while it's fresh on our minds, and we are going to edit, and after our pitch we are going to just give it a 0 there for 0 decimal points. And if we hover over this, well, we're not getting those right now. I'm going to show you how we can get those back. Anyway, we'll show you that in a second. So if we hit OK there, then it did clean that up where now we have 0 decimal points there. So that's fine when it's in this type of ratio of 1 to 48 or even 1 inch to 12. But if we start going the other way of, say, like 2 feet in 12, then it's going to start to break because it's rounding to 1. If we go 3 feet, it may even show 0 because it's rounding down. So it starts to become a little bit of an issue here when we have numbers that it's already trying to round for us. So it works up to a certain point. So that's just something to be aware of. But I don't know if I've ever seen a 3-to-1 pitch roof, so it may not be something too applicable in this case. So, okay. So that's kind of nice right now. I like that, having a nice clean number without the decimals, but again, you can pick and choose what you want to do there. You can carry 1 decimal if you want. It doesn't really matter. So, okay, let's go and continue on with this. And we are going to do a different option on this one. So we are going to kind of flip this one around, and I'm going to bring back our PowerPoint slides here once again. So we've already done this one. Our next one is going to be the kind of the opposite of this, where we have a fixed run in this case. So we're going to set our fixed run to 12, and then we are going to calculate the rise based on that. So in this case, we're going to be using a little different formula and a little different concatenation here, where we are going to have our variable up on the front side, which is our rise, and then we're going to set our back end to the 12 as our baseline. So, okay, let's go ahead and we're going to jump over here and back into our expression editor. And what we'll do in this case is we're just going to duplicate this one. So I'm going to just drag a copy, and we are going to switch this around where it is our XX to 12. And I'm picking 12 in this case because it is a very common number that we'll see here in the US for this type of scenario here. So, okay, let's go ahead and we are going to go in and we're going to make some edits here. So in this case, we are going to be structuring this a little bit differently, and what I'd like to do here is sometimes when I work with these, I like to just kind of put things on different lines here so that we can work with them a little bit easier, and we can kind of see these different parts. And what I'm going to do is, for now, I'm going to cut out that that decimal point there, and from here, we are going to start rearranging things a little bit. So, so number one is we are not going to be using our 1, we're going to be using our 12. So we can take this, and I'm just going to cut that, and we are going to add a comma here, and we can place that value there. And let's see if this is going to work for us here. So, okay, I feel like I'm starting to break this apart a little bit. Maybe it's a little confusing. So let's try to reel this back in. So the other thing that we need to do here is we need to pull out our 1 divided by, because we're going in the other direction in this case. So we have our concatenating of our and our string of our tangent with our pitch, and beyond this value, let's see, Trying to pull out where we've gone wrong here. I know we wanted to add in our multiplied value there. Let's see, what's it telling us? So concatenating of our string with our tangent and our pitch all in one. And okay, so we are missing a parentheses here. It does say we have a syntax error. So if we're taking this out, we have our tangent pitch, and we're not encapsulating everything that we're converting here to a string. So in this case, let's add a parentheses, and okay, so that seemed to resolve it here for us. And the reason we're multiplying this tangent with the pitch by 12 is because that helps create, it multiplies our rise so that it's in the same equivalent as our run here. So that's why we added that extra 12 there for the top half or the rise part of our formula. So let's go ahead and hit OK. And let's hit OK once again. And let's go in and let's jump into our Autotext, and we're going to add our latest version here. So, okay, so this is actually, I can tell that that's 1/4 of 1 to 12. So that is telling me, of course, that this is a 1/4. So let's just play with this a little bit. Let's go like 15 inches and 12 and just see what that does. So that's working pretty well there. I can see that those decimals are coming back, which is okay in this case, but it would be a little cleaner without those. So again, we could jump into that formula and make those adjustments. But yeah, really at this point, we can keep tweaking with this and you know, pick and choose which values we want to use based on our different roofs. So, okay, so that would be our next one where we have our fixed version there. And now we can see that this one is getting broken. So I think in this case, it probably is useful to keep that decimal in there on at least that first one that we started with. So let's go back in and we are going to at least edit this, and we can at least take this to 1 or we can take this to 2. Doesn't really matter. It's always good to remember that when we convert things to a string, it's going to round it. If we don't put anything there, it's going to cut out any decimals. If we put a decimal value there, then it will take it to that decimal. And so here in this case, we should see that that does become a correct ratio. And so it's just a rounding error if we are not paying attention to it. So important to pay attention to it. Okay, so this next version here that we are going to be calculating is going to be one that's going to give us a much more useful output here when we are working in small slopes, as we want to in this particular scenario. So all of these are fine for right now. What we'll want to do is, in this case, is to get a little bit cleaner of a label coming out of this. What I want to do is walk through the setup of several different if scenarios. And so we're going to bring back our PowerPoint slides once again. And so again, what we're going to do is for the condition of when the pitch is less than 1 inch, then we want to output and round these things to 1/8 inch increments. Now it's going to get a little bit complicated. It's going to be a lot of kind of plugging and copying values over from this little chart that I've set up here, where we have our exact degree slope based off our 1/8 inch to 12 inches slope here, and we're going to be plugging in our ranges for the low and the high so that we are rounding things to the appropriate 1/8 inch slope. So that's what these low and highs here are. At 0.06, if it's 0.3, then we're going to round up to 1/8. If it's 0.88, then we're going to round, or 0.89, then we're going to round down to 1/8. If it's 0.90, we'll round up to 1/4, and vice versa from 0.48 down. So hopefully that makes sense by looking at that. And again, what we're going to do there is we're going to set up several if scenarios to calculate all of those for us. So let's go ahead and we are going to jump into it. So, okay, here we are. We are going to just copy this for, once again. So this is going to be our slope pitch, and this is going to be a 1/x fractions is what I'm going to call it. And we are just going to jump in and we are going to start building this up. So we'll just start by clearing this out, and then we will go through and start building this up. So this is going to be a long formula, just to warn you, but there's going to be a lot of copying and pasting and then adjustments to it. So, okay, we're going to start this out with a logical formula that we are doing an if. And so with this, we have a logical check here. So if this logical is true, then we have a value that is true. If this is false, then we have a value that is false. So that's the main setup here on this condition. And if it's false, this is where we can stack several different values here. So yeah, let's go ahead and we are going to start getting into it here. So let's do this. We are going to start with our pitch, because our pitch is going to be the check in this case. So under our logical, let's go in and we are going to go down and once again find our pitch. So this is our pitch and what we are going to be checking. And so let's just do one kind of test scenario here, and then we will get this working right, and from there we'll start building this up. So let's just do a test scenario here that if our pitch is less than 1.00, the value, if true, in this case is going to be something that we will want to be putting in parentheses first. So we're going to just say less than 1 in parentheses, and our value, if false, is going to be more than 1. So we're just going to do a little test scenario here to see if we can get this working. Now, okay, so all arguments must use the same data type and compatible units. Now, it's telling us here that we have an issue with our arguments. So what are our two arguments? Well, our pitch is one argument, and the value 1.00 is our second argument. Now, it's telling us they're not the same units. So what's going on here? Well, if you think about it, our pitch in this case is actually a number that contains a degree symbol. So if we want to make these two equal, then in this case we need to convert our pitch to a number. Hopefully this makes sense. But what we need to do is, let's do this. Sorry, I'm gonna try to write this out a little bit. So I'm gonna do a snip of this, and then we're gonna try to mark this up. So if our pitch here, and don't mind my scratch here with my mouse rider, has a degree, and we take that over anything with a degree, so like 1 degree, then what we're doing here is we are canceling these two things out so that our pitch over 1 just equals a number. That's what we need to do here, is we need to get rid of that degree symbol to convert our pitch to a number. So hopefully that makes sense. You'll see here in a minute. So what we'll do in this case is we're just going to divide by 1, and we need to go into our measurements here, and we're looking for our angle, and we know our pitch is calculated in degrees. So by doing that, we have now converted our pitch to a number, and so now we have a number checking to see if it's less than a specified number in this case, which is 1. So okay, let's go and run a check on this, and let's hit OK. And so we're going to add this value here. So let's go back in, pitch ratio of fractions. Okay, so it's telling us now that it's more than 1. Okay, let's go do a quick check on this. So if we go and make an adjustment here, and we can just do this literally in degrees. So this is at 1.19, so obviously it's more than 1. If we set this to 0.9, let's see if it switches to less than 1, which it did. So awesome. So that is functioning for us. Great. So that's what I wanted to walk through there on just kind of the logic behind how we need to set up that formula in order to get that pitch to work in this if scenario. And so let's go ahead and we're going to go back and start building on this further. So, okay, so this is kind of the baseline that we have set up. The problem with this is it's only looking for one condition here. And so we're going to do this. I'm going to actually kind of try to flash this over here at the same time. And, oh, I'm just thinking, sorry. Let me do one thing here real quick. We're going to exit out of this. And I'm going to use this little bit of like white space that we have over here. And I'm going to take my chart and I'm going to try to paste that in here. A little larger than I would have liked, but come on. That way we can have all these numbers on the screen and you'll see what I'm doing as I'm doing it. So, okay, let's try to stretch this down without, I don't know why I'm struggling with that, but okay, we're just going to zoom in here and okay, good enough for right now. We can go a little smaller, doesn't matter. We're going to skew that one, who cares? Okay, so with this, we're going back into our property manager. And so now I can see our different ranges there. And so now we can go and we can reference these. So for this first scenario, if our pitch is, let's go in, if our pitch is less than, I'm actually going to add one more condition here. If it's less than 0.3, then we are going to set this to be a value that is, oh, let's see. We can either say it's 0 or it's going to be like 1/16 inch to 12 inches. Now I have found here that like right now we have no errors, but if I actually plug in the inch, then it kind of kills our expression here because we have to put these things in parentheses. So if you do 1 inches here, then if you give it 2 apostrophes, then that does work. So we'll go with that. We'll do the 2 apostrophes because that doesn't kill our formula. So, okay, so there we have it. We have 1/16 inch to 12 inches. And so if it's more than that, sorry, I'm going to actually change this to 0.29. So if it's less than that, we're just going to say it's 1/16 of an inch. Okay, and if that is not true, then we are going to be stacking up another if statement here. So we don't need this one, and in fact, I'm going to give this some space. And what we're going to do on this next one is we need to make a little bit of a modification here. So we are still using an if statement. So let's go ahead and we're going to add our if statement. So this is a logical function that is an if. And what we need to do on top of this, though, is we need to add a and condition. So we're going to be doing an if and. So we are looking, essentially we're replacing this logical with what we've just added right there, 2 logicals. And then we have a value of true and value of false. So our logical one is going to be our pitch is, we're going to just copy this in. We're going to be doing a lot of copying here. So if our pitch is greater than 0.30 and our pitch is, in this case, we're going to be doing less than, what's our next value? 0.89. 0.89. Then the value, if true, is we're just going to copy this entire thing here and we're going to modify. So our value, if true, is going to be 1/8 inch to 12 inches. Okay, so that is kind of our golden formula here. And every time we do this, I think we need to add a parentheses. So the value, if false here, is going to be something that at the end of the day, we'll just need to plug in a value here. So the number of arguments is not correct for this function. So let's do a little check here as well. And okay, so we're going to pull this back. So if our pitch over 1 is less than 0.03, is greater than 0.03, and our second condition is our pitch over 1 is less than 0.89, then we're looking for 1/8 inch over 12 inches, and we have a syntax error. So we're going to add this. Number of arguments is not correct for this function. So where are we missing? Oh, let's see. I think let's see. Not applicable. So somewhere in here. So we have our if and. Okay, so I think we need to cap off our and. So let's add a parentheses there. Okay, so that's what we were missing. We were missing the encapsulation of our two logical tests there. So, okay, sorry about that. That took a little bit of thinking through and troubleshooting. Sometimes you miss one parenthesis and things go haywire. So, okay, so now that we have this, we're going to do the exact same thing, and we're going to repeat it over and over here. So we're just going to kind of paste all this all the way down, and we're going to copy, and we're going to do our next scenario, and we can check if this is working by just adding another parentheses every time we do this. So, okay, so this next one should be fast. We're going to go if it is greater than 0.90 and less than 1.48, then we are going to set this to 1/4 inch to 12. Cool. So let's keep going. So this next one, we're going to tack on another parentheses. And so if we are less than 1.49, sorry, greater than 1.49 and less than 2.08, then we are going to 3/8 inch. Okay, cool. Copy, paste, parentheses. So this is 2.09 going up to 2.68. Cool. And oh, sorry, this is going to 1/2 inch. Okay. Parentheses. So this is 2.69 to 3.27, and that will be our five-eighths. Okay. The next one here, I'm going to change this one first just so I'm looking at the right line over there. So 3/4 inch is going to be our 3.28. And this is going up to 4.46. This is going to 7/8, which is 4.47 up to 5.05. Sorry, I jumped there. 3.88. $4.46. Okay, and we can do one more here. Actually, we don't really need to. We don't need this last one, because if we're going up to... No, let's actually add that. Sorry. Okay, so our last one here is going to be 4.47 to 5.05. Then this is going to 1 inch in 12 inches. Okay, and we didn't add that last parentheses there. So, okay, so this now should be working for us pretty well. And it's got me thinking, I don't know if I like this 1/16 inch. I think maybe it would be best to actually remove this and add, I think we're going to do this. I'm going to copy this. I want this to actually be able to calculate 0 if needed. So we're going to add in one more down here. And so if our pitch is less than, we're going to just say 0.15, then we're just going to say 1/32 inch to 12. And what we'll do is we're going to add in one more variable here, just in the event of something's really small. And so we're going to go from 0.16 up to 0.29, and that's going to capture our 1/16. So we kind of created like two other little scenarios here beyond what we had on our original list. And if we add one more parentheses, then there we go. So that is our formula. Now, it definitely helps to have this kind of broken out like that as we do. I'm going to take a little snip of it just because it's kind of pretty. And once we close this, it's going to collapse on itself. It's going to take out all unnecessary spaces. So there we have it. And there's our formula. So if we go back in, you'll see that's just going to be one long mess, which is actually a lot more difficult to interpret. So, okay, with that, let's go ahead and we're going to hit OK on this one. And we are going to, well, yeah, we can see here that, let's do this. So we can see that is already calculating at 1/4 inch, because before it was either the more than or less than. And so based on that, let's see if this is going to work for us. So if we go to like a 3/8 inch, cool, it goes to 3/8. If we set this to some random value or like 3/16, what does it give us? Okay, so it's giving us a NA in this case. So maybe it didn't pick up our value there. Because of those ranges, it should have. So if we go to 3/4, then let's just double check that. So 3/4 in 12. If we go to 1/16 inch, so it's jumping back to that. What happens if we go to 1 in 12 inch? So that's rounding to 1/8. If we go to like 11/64, still rounding. Let's go to 16/64. So okay, so that's converted it. So okay, so we are now functioning here. Let's set this to degrees just so we can check these a little bit. So if we set this to 0.31, where does it put us? 1/8 inch. If we set this to 0.25, 1/16. Okay. If we go less than that, 0.1, 1/32. Okay, so that is working pretty nicely there. If we go to like, what would it be? Like 8 degrees is giving us our NA. So in this scenario here, what we really want to do is we want to account for those conditions where we are 1 inch and over. So we are at 1 inch right now. And what I'd like to do is just kind of bring this formula along that we did with that first ratio and bring it in and add that here. Or we can pick and choose which one we want to use. So we're going to go one step further with this, and we'll jump into our property manager. And just so that if I break this, I'm going to make a copy of this. And so I have a backup there. And what we'll do in this case is we're going to add another if scenario. But first, I think I'm going to choose to go with, in this case, we'll do this formula here. And so we're going to copy this, and we're going to bring this over, and we're going to be modifying our original here just because we have our backup just in case. And so what we'll do is we're going to be adding another condition here. And actually, if none of these conditions are met, then we can just simply replace it here in this last where we have our NA formula. So we're going to paste that in there. Expression contains a text that cannot be identified as pitch. So we are going to go back in. It's interesting how it didn't pull that through, but let's go in. We're going to add our pitch. And okay, so we should be working here. And so all we've done is in the false condition, if none of these are met, we're just adding in that original of 1 to whatever the value is there. So let's see if that's working. Okay, so we're at 1 inch to 12. If we go to 2 inches, then we can see that that went to that 1 to 6. So that is working for us right there. So 1 to 3. So really it's up to us if we want to, which one we want to use. If we want to keep it on like where everything is going to 12 inches, then maybe we use that other formula instead. So we can pick and choose for sure whichever one we want to deploy. So that was that's a pretty big training there on expressions, and I hope that this was useful for you. You can see that we've now built up a pretty nice collection here of different slopes that all equal each other on this particular project or on this particular roof. So what's nice now is we can take this and we can really apply it to any roof that we want. So we can add this in, and there we have everything in this case. So this is a 15 to 12 slope, which we can see right from there. And of course, we don't have to list all of this. We can pick and choose just the few that we want. So maybe we just want to use that one, and fine, there it is. We can clean this up, make it larger if we want. And I think we've explored how to go in and manipulate and remove decimals, and as well as add new inches here, or 2 apostrophes to represent an inch into those if desired. So, okay, that's pretty much what I got here for today's video. I know that was a lot to cover, but hopefully walking through and building up these formulas was useful and fun. So play around with it on your own. I hope you enjoyed. If you have any questions on this, then let me know, and we'll catch you on another video here on Archicad soon. Again, if you're interested in learning more about expressions, then I'll post a link in the description, and you can go and register your interest. I actually have a form set up on the website that if you have any specific expressions that you want to learn, then you can go in and plug in the form what expressions you're interested in, and we'll either create a YouTube video or we will include it as one of the samples in our upcoming Archicad expression-based properties training course. So hope you enjoyed. Thanks for watching, and we'll catch you on another video soon.